Hey guys, what's up? My name is Chloe and I'm a private pilot. This is my little co-pilot, Poppy Chulo, and today we will be reading the next section of the Instrument Pilot Oral Exam Guide, 11th edition by Jason Blair. We are up to Chapter 1, Preflight, Section F, Flight Instruments, which is further subdivided into pitot-static system, gyroscopic system, magnetic compass, and electronic flight display. This is a really long chapter and section. It took me a while to get through it. I have brought it down to its most essential parts, and it also deals a lot with how the instruments actually work. When it comes to those questions, I will be reading directly from the book, lest I say anything incorrect, and that is no bueno, because this stuff is hard enough for us to then start pulling out wrong information from stuff we've heard online, like this video. So, yeah, just like with the other videos, remember this is written in question and answer format. I will read the question in my mother's very Brooklyn accent just to keep you entertained, and then I will read the answer in my normal speaking voice. I will also add where in the FAA handbook, FAR AIM, advisory circular, etc. more information on that subject can be found, so you can go look it up. Okay, without further ado, Chapter 1, Preflight, Part F, Flight Instruments, Pitot-static System. What instruments operate from the pitot-static system? FAA Handbook 8083-15. The altimeter, the airspeed indicator, and the vertical speed indicator. They all receive static air pressure. The airspeed indicator receives both pitot and static pressure. Question 2. How does an altimeter work? FAA Handbook 8083-15. So, ambient air pressure is pushed into the housing unit from the static port, okay? Inside the housing, which is the container of the instrument, are aneroid wafers. Those are discs filled with gas. Those discs expand and compress when the pressure changes, and they actuate the linkages to indicate on the face how high the aircraft is above the ground. All right, question 3. What types of errors is the altimeter subject to? FAA H 8083-15. Mechanical errors. Differences between ambient temperature and or pressure can cause errors on an altimeter. That refers to mechanical errors. And inherent errors. Errors with respect to non-standard temperature and pressure. So for example, in warmer than standard, when it's warmer than standard, and standard is referring to the ISA, the International Standard Atmosphere, so 59 degrees Fahrenheit, 15 degrees Celsius, 2.902 inches of mercury. So in warmer than standard air, the air is less dense and pressure levels are further apart. Therefore, the pressure level at a given altitude is higher than if it were at standard temperature. So you are higher than you think you are, meaning true altitude is higher than indicated altitude. You, that says how I think of you, is true altitude is higher than you think you are. Think being what you're only thinking it because it's indicated altitude. It's altitude that's indicated on the altimeter. In colder than standard air, the air is denser and pressure levels are closer together. So you are lower than you think you are. The true altitude, you are truly lower than the indicated altitude, the altitude indicated on the altimeter would have you think. In extreme cold altimeter errors, the book says between 10 degrees Celsius and negative 50 degrees Celsius to add a cold temperature correction. High pressure to low pressure. There's another inherent error of the altimeter. So going from high to low without adjusting the altimeter, an area of high pressure to low pressure without adjusting the altimeter, high to low, look out below, right? So you will be true altitude lower than you think you are, than it indicates on the altimeter. Going from low to high, clear the sky. If you went from low to high and you didn't adjust the altimeter, you will be higher than you think you are. Follow? So high to low, look out below. Hot to cold, look out below. below. All right, question 4. What's the maximum allowable error for an altimeter? 8080 FAA Handbook 808315, 14 CFR 43, Appendix E. So you just have to be within 75 feet of field elevation. Okay, question 5. State and define the different kinds of altitudes. So you have indicated, true, absolute, pressure, and density altitude. Indicated altitude is the altitude that's just read from the altimeter after it's been set to the current altimeter setting. And you set that in the Colesman window. True altitude is the vertical distance above sea level. It's mean sea level. So airport, terrain, obstacle elevations on charts are given true. Absolute altitude, that is the height above the terrain, AGL. Pressure altitude, the altitude when the altimeter is set to 299 or 2 inches of mercury. Density altitude is the pressure altitude corrected for variations from standard temperature. Question 6. Does adjusting the altimeter setting have an effect on the altitude displayed to controllers? FAA Handbook 808315. No, it does not. Question 7. What is the function of the Colesman window on the altimeter? FAA Handbook 808315. It allows you to adjust the altimeter setting. I think they just want to know that you know what the Colesman window is. That's it. Because if you're at this phase already, you've set a few altimeters. All right, question 8. How does the airspeed indicator operate? FAA Handbook 808315. Basically, it takes the difference between the ram pressure from the pitot head and the atmospheric pressure from the static source. Question 9. What are the limits that the airspeed indicator is subject to? FAA Handbook 808315. There must be proper airflow into the pitot-static system. Question 10. What are the errors that the airspeed indicator is subject to? FAA Handbook 808315. Position error, density error, and compressibility error. So position error is when the static ports sense erroneous static pressure. Density error is when changes in altitude and temperature are not compensated for by the instrument. And compressibility error is when air is packed into the pitot tube at high air speeds, causing abnormally high indications. This usually occurs over 180 knots of indicated airspeed. All right, question 11. What are the different types of aircraft speeds? FAA Handbook 808315. Indicated, calibrated, equivalent, and true. The indicated airspeed is that airspeed which is uncorrected for instrument or system errors. Calibrated is the indicated airspeed corrected for instrument and position error. Equivalent airspeed is calibrated airspeed corrected for compression of the air in the pitot tube. That would equal calibrated airspeed at international atmospheric standard conditions. And true airspeed is the calibrated airspeed corrected for non-standard temperature and pressure. Question 12. What airspeeds are indicated by the various color codes found on the dial of an airspeed indicator? FAA Handbook 8083-25. The white arc, the flap operating range, lower limit of the white arc, VSO. I'm assuming you know what the V speeds are. Upper limit of the white arc, VFE. Green is the normal range. Lower limit of the green is VS1. Upper limit of the green is VNO. Yellow arc is the caution range, and the red line is VNE. How does the vertical speed indicator work? Right, as per Jason Blair, the vertical speed indicator is a rate of pressure change instrument that gives an indication of any deviation from a constant pressure level. Inside the VSI instrument case is an aneroid. Both the inside of the aneroid and the inside of the instrument case are vented to the static system. The case is vented through a calibrated orifice that causes the pressure inside the case to change more slowly than the pressure inside the aneroid. Changing pressures inside the case and the aneroid compress and expand the aneroid, moving the pointer upward or downward, indicating a climb, a descent, or level flight. unquote. Okay. Question 14, what are the limits of the vertical speed indicator? FAA Handbook 883-15. The VSI won't be accurate until the aircraft is stabilized. Question 15, this is a hypothetical question. You're en route in IMC and ATC clears you to climb to a new altitude. As you climb, the altimeter and VSI indicate a climb, but your ASI shows increasing airspeed. What could be the problem? FAA Handbook 883-15, 883-25. The pitot tube is probably clogged, and in that case, the airspeed indicator is acting as an altimeter. All right, question 16. All right, how about as you're climbing into IMC and your VSI reads 0, ASI is alive but seems inaccurate and the altimeter is frozen? FAA Handbook 883-25. In that case, the static system is probably blocked. All right, skipped a few, and then question 19. What would you do if the static port freezes over? FAA Handbook 883-15. If there's static heat, you turn it on. You can use alternate air, or you could break the glass on the VSI to provide the ASI and altimeter the static pressure. Because the VSI is not needed for instrument flight, by the way. Question 20. If you use an alternate source of static pressure vented inside the plane, what instrument indications would you see? FAA Handbook 883-15. The altimeter would read higher than actual, the ASI would be greater than actual, and the VSI would momentarily show a climb and then stabilize if in level flight. All right. Part F, flight instruments, gyroscopic systems. Question 1. Which instruments have gyroscopes? FAA Handbook 883-15. The attitude indicator, the heading indicator, and sometimes the turn coordinator. Question 2. What kinds of power sources are usually used to power the gyroscopic instruments? The book says electrical, pneumatic, venturi tube, wet-type vacuum pump, and dry air pump. My CFII says electrical and caged. Question 4. What are 2 important characteristics of gyroscopes? FAA Handbook 883-15. Rigidity in space and precession. The attitude indicator and heading indicator operate on the principle of rigidity in space, and the turn coordinator operates on the principle of precession. So, question 6. What is a standard rate turn? 3 degrees per second or 360 degrees in 2 minutes. Question 7. What information does a turn coordinator provide? FAA Handbook 883-15. The miniature aircraft shows the rate of turn, rate of roll, and direction of turn. And the ball in the tube shows the quality of turn. It would show if you're in a slip or a skid. So a slip is when the ball is on the inside of the turn. That's not enough rate of turn for the amount of bank. Slips are good. A skid is when the ball is in the outside of the turn. Too much rate of turn for the amount of bank. Skids are bad. Actually, I love to slip an airplane. That's one of my most favorite things to do with the plane. Question 8. What is the source of power for a turn coordinator? FAA Handbook 883-15. Usually they're electrically powered. Question 9. How does a heading indicator work? 883-25. All right. Okay. According to Jason Blair, the operation of a heading indicator works on the principle of rigidity in space. The rotor turns in a vertical plane, and fixed to the rotor is a compass card. Since the rotor remains rigid in space, the points on the card hold the same position in space relative to the vertical plane. As the instrument case and the airplane revolve around the vertical axis, the card provides clear and accurate heading information. Okay. Question 10. What are the limits of the heading indicator? FAH 883-25. It depends on your plane, but they can be 55 degrees of bank and 55 degrees of pitch. When those limits are exceeded, the instrument will tumble or spill and no longer give a correct indication until it is reset with the caging knob. Question 11. What type of error is a vacuum-driven gyro heading indicator subject to? FAA Handbook 8083-25. An error caused by precession. Also, because the Earth rotates at 15 degrees per hour, the heading indicator may indicate as much as a 15-degree error per hour. Question 12. How does a vacuum-driven gyro attitude indicator work? 8083-25. So, the gyro in the attitude indicator is mounted on a horizontal plane and depends upon rigidity in space for its operation. The horizon bar represents the true horizon and is fixed to the gyro. It remains in a horizontal plane as the airplane is pitched or banked about its lateral or longitudinal axis, indicating the attitude of the airplane relative to the true horizon. Okay. Question 13. What are the limits of the attitude indicator? FAA Handbook 8083-25. With bank, it's 100 degrees to 110 degrees and pitch 60 to 70 degrees. All right, almost done. Flight instruments, now we're up to magnetic compass. So, question 1, how does the magnetic compass work? The book says, magnets mounted on the compass card align themselves parallel to the Earth's lines of magnetic force. FAA Handbook 883-15. Question 2, what limits does the magnetic compass have? FAA Handbook 883-15. An 18-degree angle of bank beyond which the compass indications are erratic and unpredictable. Question 3. What compass errors must instrument pilots be aware of in their flight operations? FAA Handbook 8083-15. Oscillation error, so that would be erratic movement of the compass card caused by turbulence or rough control techniques. Deviation, which is the devious electrical and magnetic disturbances in the aircraft. Variation, the angular difference between true and magnetic north. And then there's dip errors, which include the acceleration error and the northerly turning error. As we remember from our private pilot days, acceleration errors refer to ANS. So when you're on an easterly or westerly heading in the northern hemisphere, if you're accelerating, there'll be a trend to the north. That's what the magnetic compass will show, a trend to the north, and decelerating will be a trend to the south. Okay, editing Chloe here. I heard myself talk about undershoot north, overshoot south, that northerly turning error, and I had gotten it slightly wrong. So let's just correct it. Undershoot north, overshoot south refers to when you're making a turn in the northern hemisphere from a northerly heading. Your magnetic compass will lag and then go in the correct direction of the turn. And when you're making a turn from a southerly heading, it will go in the correct direction of the turn, but at a faster rate than it is actually occurring. That is UNOS, undershoot north, overshoot south. Okay, back to the video. Now we're up to the final part of this chapter and section, the electronic instrument displays. All right, so question 1 is describe the primary flight display, multifunction display, attitude, heading, and reference system, and air data computer. So the primary flight display, the PFD, is a replacement of the traditional 6-pack with a display that shows the horizon, airspeed, altitude, vertical speed, trends. It is designed to increase situational awareness. Multifunction display is going to show all the nav data, like moving maps, and it shows aircraft systems information. If needed, it will show some PFD information. The attitude, heading, and reference system is an integrated system with a 3-axis sensor that provides heading, altitude, and yaw information. And the air data computer receives and processes ram air, static air, and temperature information from sensors, and provides information like altitude, indicated airspeed, vertical speed, wind direction, and wind velocity to the primary flight display, the AHRS, transponder, and any other flight deck systems. Question 2. What is the function of the magnetometer, FAH 883-16? It measures the strength of the Earth's magnetic field to determine aircraft heading and gives information to the AHRS, bringing it to the primary flight display. AHRS, again, is attitude, heading, reference system. Question 3. Does the plane have to remain stationary during AHRS system initialization? FAA Handbook 883-16. Sometimes, but you have to check your AFM and POH. Sometimes It could be initialized during taxi or in flight. Okay. Question 4. If the primary flight display or multifunction display fails, what happens to the remaining operative display? So PFD conks out. What happens to the MFD? FAA Handbook 8083-16. So some systems offer a reversion such that the information on the remaining display will show whatever the system on the out of service display was going to show. So my CFII was explaining that if the primary flight display went out on the MFD, there would just be like a little rectangle that would look a lot like the PFD and vice versa. That would show up on the MFD. All right, question 5. When a display failure occurs, what other system components will be affected? In some systems, there will be a partial loss of navigation, comms, and GPS capability, but you have to consult your AFM and POH. Question 6. What display information will be affected when an air data computer failure occurs? FAA Handbook 8083-16. You'll see red X's on the airspeed, altitude, and vertical speed indicators. Question 7. What display information will be lost when an AHOS failure occurs? FAA Handbook 8083-16. You'll see a red X on the primary flight display. Question 8. How will loss of a magnetometer affect the AHOS operation? FAA Handbook 8083-16. Heading information will be lost. Question 9. If you experience an alternator failure and your electrical system is being powered by the main battery, do you immediately lose any equipment functionality? How long will the systems continue to operate before the main battery fails? FAA Handbook 8083-16. Between 1 hour and a few minutes, depending on the electrical load and the condition of the battery. All right, and finally, question 11, what items still receive power from the standby battery if there's an alternator failure and depletion of the main battery? So you get everything powered by the essential bus. That would include the most critical aircraft equipment, the AHRS, the ADC, primary flight display, nav radio 1, com radio 2, and standby indicator light. Guys, this was a lot. If you're still here, hats off to you. And we will be back very, very soon with the next and I think last part of Chapter 1 Pre-Flight, and that has to do with the weather, which is at least a little bit more exciting than some of the mechanics of the instruments, because guys, this was a lot. This was a lot for Chloe and Poppy. It was, especially Poppy. I think he stayed awake all the way to the magnetometer, and the word magnetometer was an instant cure for his insomnia. All right, guys, Poppy and I will see you in the next video very, very soon. Right, baby? Bye. Bye.